and this will be uploaded. It's kind of weird when I do these videos. It's being recorded through Zoom on the cloud, and then it takes, you know, like an hour or two for Zoom to tell me that it's there, and then I have to go download it to my computer, and then I have to upload it to YouTube. So it takes me a while to get it done. So it may not be today, but it'll be, you know, hopefully by tomorrow.
I posted a screenshot of how it looks with the submission on the grade.
Oh, in the chat?
In the chat.
Okay, if anyone wants to look at the screenshot, Sarah shared something there if you want to take a look at it. Thank you.
You're welcome.
Okay, all right, so let's get these grades out of here.
I can't get it. I somehow got this thing all small. How do I get it bigger again? The screen.
What screen?
Like I see your, you know, what you're sharing, but it's a little small square. I can't get it back to big.
Do you have like a little small bar, big bar, this thing right here in the top corner? Do you have that on the window? Like where you normally close the window, do you have a maximize, minimize?
No.
No?
Nuh-uh. I don't know what's going on here. I accidentally clicked on one of the windows or whatever, and it's made it small. I can't make it big again.
Can you close it?
When I double click it. Okay, there it is. Okay.
You got it?
Click on the Zoom thing again.
Okay. Okay, so let's talk about factoring. We've already actually discussed factoring just a little bit. Remember when we did GCF, greatest common factor?
Mm-hmm.
So the whole idea behind factoring is taking an expression and changing it from additions and subtractions to some sort of multiplication. So just to remind you, let's just do a very simple example. If we had like something like 2x squared minus 6x, and you were asked to factor this, the thing that we talked about before is this thing called GCF, greatest common factor. So what we would do is we'd look at the numbers 2 and 6, and we would try and figure out the biggest number that goes into both of those. So in this case, 2 is the biggest number. So we would write 2. And then we look at the letters, the variables, x. We'd see how many we have in each term. So we have 2 x's in the first term and 1 in the second term. So we want to pull out the most that appears in both terms, which would be 1x. So we pull an x out, and then we put a set of parentheses, and we leave enough space for 2 terms, and that's because the original problem had 2 terms in it. And then what we do is we figure out what we would have to put in there in those blanks so that when we distribute the 2x through, we get back the original problem. So this is all review. This should somewhat look familiar because we've done it.
Mm-hmm.
So we would have to put an x here, and we would have to put a -3 here, so that when we distribute through, we get back 2x squared minus 6x. Does that ring a bell? Everyone comfortable with that? Okay.
Mm.
So that is known as GCF. But that's all we've talked about in terms of factoring. So what we're going to do now, I'm going to give you kind of a set of steps, all right, on how to factor. Okay, so how to factor. All right, the first step to factoring anything, the first step is always GCF. You always look for greatest common factor and see if you can pull something out. That's always step number 1. Now here's where things start getting complicated. The second step, after you've done GCF, is to count the terms that you have. Okay, you have to count how many terms you have. Now, when we go through an example, you'll see me do this. All right, for now, let's just write it down. We want to count how many terms we have. And when we count them, at least in this class, there's only a couple of possibilities because we limit what problems we actually give you, right? We're not going to give you the hardest problems. So in this class, when we count the terms, if we have 4 terms, what that's going to tell us is that we need to use this thing called grouping. So that's the name of a technique that we're going to talk about today, this thing called grouping. If we have 3 terms, we're going to use something called the AC method. And if we have 2 terms, then we're going to use a special formula. So I'm just going to put a formula. Okay, so there it is, all right? That's basically how we factor. Now, it looks kind of simple. I mean, it's like you just do GCF and then it's just going to be one of these 3 things: 4 terms, 3 terms, 2 terms. The problem is each of these techniques, grouping, AC method, and the formula, those are all, there's a lot in those, you know. So we're going to start out with an example, and we're going to start out with 4 terms as an example, and then we'll work our way through down to 3 terms and 2 terms. It turns out that doing the 4 terms is actually, in order to do 3 terms, you have to be able to do 4 terms, which seems weird, right? It's like you have to learn 4 terms first, then you can do the ones with 3 terms, which is just strange, but that's the way it works. So, all right, let's go and take a look at an example. But those are the steps. Okay, so I am going to be very picky here about the ones that I choose. Right now, I'm only going to do ones that have 4 terms. So I'm going to start out here. Let's do that one right there. Let's see what we can do with this one. All right, so I'm going to do it on the side here. We have 5xz plus 20x plus 6yz plus 8y. All right, so what we want to do is we want to take that expression and factor it. So we want to try and break it down so that it's got some multiplications in it. All right, so to do that, start out step number 1, GCF. So we look at the numbers, 5, 20, 6, and 8. Is there a number that goes into all of those?
No.
No, right? There's not. I mean, other than 1, right? 1 goes in all of them, but there's no other number that goes in all of those. So we don't have a number that we can pull out. How about letters? Let's see. We have an X, we have an X, but we don't have any other X's throughout the whole thing, right? So we can't pull an X out. How about Y's? Well, we have a Y here and a Y here, but we don't have a Y in the first 2, so we can't pull a Y out. Remember, it has to be common to all of them. And then Z's, do we have Z's everywhere? No, Z there, Z there. So we only have Z in 2 of the terms. So there's really nothing that they all have in common. Would you all agree with that? We have no GCF. Yes?
Yep.
Okay, so step 1, GCF, we can say, yeah, check. I mean, we've done it. There's nothing to do, though. All right. So what's step 2? Step 2 is to count the terms. So we have 1 term, 2 terms, 3 terms, 4 terms. So for step 2, we have 4 terms. And what does that mean we have to use? Grouping, right? That's the technique that we're going to use for this. Okay, so how does grouping work? Well, what we're going to do is, I think what I'm going to do, I think I'm going to work this out on a different page just to give myself some more room. Okay, so we have 4 terms, so we're going to do grouping. So here's the way grouping works. You're going to go to your first term, second term, and immediately after your second term, I just want you to draw a line. Okay, that's the way grouping works. What we're going to do right now is we're going to group this problem of 4 terms into 2 different problems. So I'm going to just look and focus all of my attention right now on just the first 2 terms, and I'm going to ignore the other 2. On those first 2 terms, do you have a GCF?
Yes.
Just
Yes. Okay, so we do. A number we could pull out of both is 5, and they
Right.
both have an x. So I could pull a 5x out, and that would leave me with a z plus 4. Now, this is something we've done before, and I'm not expecting that you would be able to get it like that quickly, but I do expect that you could do that you could establish that distributing the 5x back through would give you back that top line. Is that all right with everyone?
Mm-hmm.
Okay. So now what you're going to do, okay, after you've done that, let me erase that, make that line a little smaller. Okay, now what you're going to do is you're going to do the same thing for the second 2 terms. Okay. So is there something that you can pull out of both of those? Is there a GCF there?
Yeah.
So what about
40?
a number? What number
40?
goes into both of those? 3?
40?
2.
Oh,
2?
2. Oh, yeah.
Right, 2. Okay, so 2 goes into both those. So I'm going to put a 2 here. Now notice I left a space here. Just hang tight. That's a 2. How about they both have a y, don't they?
Yeah.
And that's it. That's all they have in common. Now, what would go in that parentheses if I wanted that to be able to distribute back through and give me back what I have in green?
Z plus y.
4.
3z, right? I need a 3z
Oh, yeah.
plus 4, right? Okay, now where I put that arrow here, I said leave a space there. It's very important at this point that we put something in between there. And what we're going to do is we're going to look at, you know, this 2y that we pulled out. It was positive 2y, wasn't it? I mean, it's not a negative number. We pulled a positive 2y out. So I'm going to put a plus sign here. Okay, now, for those of you who've maybe done grouping in the past and you've seen this before, can anybody tell me what happens now, or whether or not we have a problem, or whether or not we can keep going? Or
Don't we have to distribute?
you mean multiply this through?
Yeah.
Well, if we do that, we're gonna get back to the original problem, aren't we?
Yeah.
Yeah, that's right.
So we're not wanting to reverse this. We're trying to go the other direction. We're trying to get multiplications together. So at this point, okay, and this is where grouping can be a little bit tedious and troubling, is that it's vital at this point that for grouping to work, because grouping doesn't always work, okay? I have bad news here. Like factoring is tough because sometimes it works and sometimes it doesn't. In order for this to work, whatever you have in this parentheses and whatever you have in this parentheses, they must match each other. So right now, do those 2 things match?
Oh,
No.
they don't. Yeah, they have.
They
Z
don't.
and-
They're not the
Oh,
same.
yeah. Oh, yeah.
Right? One of them is z plus 4. The other one is 3z plus 4. It doesn't match. And because those don't match,
No grouping.
okay, don't match, we are done. Basically, we have to say we can't factor this.
And if they did match?
Okay, so what I'm gonna do now is I'm going to give you right next to this one, we're gonna do a different example where it does match and then continue through. But maybe I should have started with that example, but this example, you just have to be very careful because even if you follow the steps, GCF first, okay, 4 terms, try grouping. If those 2 things don't match, you're dead in the water. You're not doing anything else. You're just done. You just say you can't factor. So you're done. Now, I wouldn't anticipate that I give you that on a test. I want to see you factor. So I don't plan on giving you problems that don't factor. I just wanted to make sure you're clear that as great as grouping can be, it's not always going to be usable. All right. So let me change the problem. I'm going to give you a new problem. 5xz plus 20. I'm just going to do a small little tweak to this. Plus 2yz plus 8y. So the only thing I changed, I don't know if you noticed this. Let me make sure it's going to work. Yeah, that should work. The only thing I changed is that 2, right? It was a 6, but now it's a 2. Okay, so let's go through the procedure again. Step 1, do I have a GCF? So is there a number that goes into all of those numbers?
No.
No, okay. And then the letters, I haven't changed anything. So there's not an X and a Y or a Z in all of them. So can't do a GCF. So then I count the terms, 1, 2, 3, 4. Once I count 4, I split it. Right after the second term, I split it. And then I do my GCF on each one again. So when I do my GCF on the first one, nothing is going to change. I'm going to get 5x, then I'm getting z plus 4. But now on the second one, what can you pull out? What's the GCF on the second group of 2? So we can pull a 2 out, right?
Put 2 out and a Y.
2 and a y. Okay, we'll put a 2 and a y, and I'm going to go ahead and put a plus there between them because I pulled a positive 2. And then I'm going to put a set of parentheses. And now what would be left?
Z plus 4.
Z plus 4. Okay. Do these match now?
Yeah.
Yeah, they match. And that's really good news, okay? Because when they match, that means you can continue with grouping. Now, this part right here is taught many different ways. Sometimes it's taught where most of the time teachers just tell their students at this point, hey, look, once you get to here, just the next line is this and just write it down. They don't explain to their students why. So does anyone know what I should write down next? Someone who's seen this before? What I should write down next? No? I mean, maybe you don't remember, so it's okay if you don't, but
Can you combine the like terms or no?
yeah, okay, so yeah, let me explain it, all right, because I want you to know why we're gonna do what we're about to do. Let me write it down first, okay? What you do is the thing that matched, right? That's the thing that matched in both. Do you agree? The Z plus 4? You write that down. And then next to it, in a separate set of parentheses, you're going to write 5x plus 2y. Now, the 5x came from here, and the plus 2y came from here. So it's like whatever matches, you write it down first. And then the two things that were in front, you put those in parentheses. And that is the factored form. We are done. Now, I'm going to explain why we do that in a minute, but let's just check to make sure it works. Does anyone have a question on what I did in terms of just like whatever matched, I wrote it down just one time. And then the things in front, I just slapped them into a set of parentheses. Do y'all understand that process? Okay, let's check that it works. If I were to ask you to check this, what we would do is we would FOIL this. We would actually multiply this out. So what would happen if I did this times this? I get 5xz. If I did this times this, I would get plus 2yz. Then when I do the inner ones, I get plus 20x. And then when I did the outer ones, I would get plus 8y. And if you look and compare that to the one above, we have 5xz. Let's see, 2yz, got it, 20x, got it, and 8y, got it. So it is the same thing, isn't it?
Yes.
So our answer, z plus 4 times 5x plus 2y. This right here is the factored version of the original problem. Factored because we now have multiplication in
Oops,
between.
sorry.
I'm sorry?
I'm sorry, that was my computer.
Oh, no, it's okay. Okay, any questions on that? I'm gonna, again, I have not shown you why it is we do that weird step where you write down the thing that matches. I'm gonna try and explain that now. And I think I'm gonna do it on the side over here. And we're gonna do more examples of this, don't worry, we're gonna get plenty of practice with this. Okay, so when we were at this step, when we were there, we went from there to here, to this step. I'm gonna get rid of some of this stuff. Ah, crap. All right, so we went from there to there. Let's see why. So to do this, I'm going to ask you something. Let's say I wrote down here, just imagine this is a completely different problem. If I asked you to look at that, 2xm plus 2ym, and I asked you to factor it with the GCF, what do they both have in common?
M.
M. So you would pull an M out, wouldn't you? And then what would go inside the parentheses?
5x.
Y.
5x plus 2y, right? Is everyone clear on that?
Mm-hmm.
Okay, so it's like when you looked at these two, they both had an M, right? And so you pull the M out, and that's GCF. What I want you to see is that in the problem above, do you see that the z plus 4 right there is kind of like the M? Like they both have an M in them, don't they? They both have the same thing. So you could pull that out front. So if I pull this out front, right? If I pull that out front, it would be z plus 4. And then what I would have in parentheses after would be whatever's left, which would be the 5x plus 2y. And that is why it turns into that. So if you understand that, great. If you don't worry about it. You can just follow the process instead without thinking too much about why. But you are actually just factoring. That's how this line here turns into that one there. It's just a factoring step. Okay, I think another one is in order. Let me, yeah, let's do this one. That's out of homework, hold on. 4, 2. Yeah, let's do, so I want to make sure I give you one that works because it's kind of sucks when they don't work. Let's do number 12 here. This one here. So we're going to have 8xy plus 12x minus 10y minus 15. So what is the first step here?
GSF.
GCF, right? So let's see.
GCF.
Do all of them have a number in common? You have to look at all of them. And it almost looks like 2, right? Until you get to the 15. 15, 2 doesn't go into 15. So you can't pull a 2 out. There's nothing, right?
Nope.
Are there X's in every single one of them?
Nope.
Nope. Y's in every single one of them?
Nope.
Nope. Okay. So there's no GCF. All right. So I'll just jot that down over here. There's no GCF. All right. So now we count the terms, and we have 4 terms, don't we? So if we have 4 terms, we're going to split it in half. And notice I put that where I split it. Notice it was right after the X on the 12, right? And I did it before that subtraction symbol. That's important, all right? It's right after that second term you place it. Okay, now look at the first 2 terms. There I do have a GCF. I can actually pull a 4 out, and I can pull an x out. And if I do that, I'll be left with what?
4y plus x.
Close. 2y, right? Because you have to turn the 4 into an 8. So you have to multiply by 2. And you already have an x, but you're missing a y. So you have to have a 2y there. Plus what?
4.
What do you have to multiply 4 by to get 12?
4 times 3.
3, right? And then you don't need an x because you already have an x out there.
I saw the
Okay,
problem.
so-
I thought that was a 2, not a 12.
Oh, you pulled a 2? Is that
Yeah,
what
I
you said?
saw instead of 12, I thought it was 2x instead of 12x.
Oh, okay. Yeah, gotcha.
And then we put the minus sign right there.
Okay, so yeah, now hold on. We're not going to put anything there
Okay.
yet. Okay, what we're going to do is we're going to see what we need to pull out here. Okay, so what is the GCF for the second two? Do they have something in common?
No.
5.
They both have a 5, don't they?
Oh, yeah.
5 goes into 10, 5 goes into 15.
Yeah.
So if I were to put a 5 out here, right now, the way I have that written, that's a positive 5, right?
Mm-hmm.
What would you need in here in order to get back negative 10y?
So negative 2?
Yeah.
You'd need a negative 2y, wouldn't you?
Yeah.
I'm going to write it down. And then what would you need to get that negative 15? What would you have to multiply 5 by?
-3.
Negative 3. Now, is that going to work?
No, because they're going to be opposite. It's not going to be.
Yeah, they don't match, right? They don't match. But they're so close, aren't they?
Yeah.
Like one of them is positive 2y, the other one has negative 2y. The one on the left has positive 3, the one on the right has negative 3. They're only off by a sign. So wouldn't it have been better for us to have said, instead of them both having a positive 5 in common, that they have a negative 5 in common? So
Yeah.
notice how I put that minus there now? So now if you look at that as a negative 5 on the outside, do you agree that this would have to be positive 2y and plus 3? So now that you distribute that negative 5 through, you still get negative 10y and you still get negative 15. That's an important part of this right there, the step that just happened.
Then you put 2y plus 3.
So now that they match, yeah, we put 2y plus 3. And then a second set of parentheses, and what do we put there?
4 minus 5.
4x
Oh, 4x. Yeah, yeah.
minus 5, which is just those two pieces that were in front. And that's it. You don't need to, but you could FOIL that out if you wanted to. And if you FOIL it, you would get back the original expression. Now, when we first started talking about factoring, I tried to convince you at least a little bit that factoring is really important in mathematics. Being able to turn something into a product, as we're going to see later on. Right now, we're just trying to learn the technique. You have to trust that it's useful. Okay, it is useful for something. Unfortunately, in this class, we don't really do a whole lot of applications, so we don't get to see a lot of it. But you know, you could use this, let's say in the real world. You know, if you've ever, I know there's not sports going on right now, but like in a baseball stadium, you know, you've got all these fans sitting here in the stands, and then you've got someone, they hit a ball, right? They hit this baseball and it's a home run. It goes over here and it hits into the crowd. And then the broadcaster says, oh, that home run, you know, went 405 feet, right? Well, when they say 405 feet, they're actually talking about where the ball would have landed had it not hit the stands. So how is it that they can predict how far that would have gone? Well, they have to actually be able to factor to do that. Like, factoring is an essential part of that calculation. If you can't factor, you can't do it. So that's just one like just basic example. But you can translate this example into, you know, the military, right? If you're trying to take out a target far away and you're going to, you know, launch an artillery shell over here and you want to know where it's going to land, you actually have to be able to factor to do that. So you'll just have to trust me when I say it's useful. I'm not sure if using military is a good example because, you know, like, hey, if you want to go kill people, you need to be able to do math. But the sad reality of the world is that that's the way that warfare in our desire to want to hurt each other as a species has definitely motivated us to advance our technology and math. Would y'all agree?
Yeah.
Yeah. I mean, think about all the advances that were made. If my recollection is correct, I believe the internet was designed. Do y'all know why the internet was created?
It was a military thing first, right?
Yeah. Yeah. So the idea was this, and I'm going off topic. I apologize. This is the United States of America. Thank you very much. I know that that's really good. So like we have certain areas, this is like during the Cold War, we have certain areas of the country, I'm not quite sure where they are, but we have certain areas of the country that are really important, where we have our major nuclear missile sites. And so, you know, we were fighting with the Soviet Union at the time, not fighting, but just we were kind of in this posturing, you know, like, you better not attack us, we'll attack you. And, you know, it's communism versus, you know, democracy, I guess. And so we had these missile sites, very important missile sites. And the fear was that if the Soviet Union launched a missile attack, that we wouldn't be able to respond. So if they knocked out our missile sites, that they would wipe us out before we could retaliate. And so what we were trying to do was create a system that you know, because these stations were connected to one another, communicating directly through these lines. And we were like, okay, how can we make it so that if they knock out the lines, they can still communicate? And so what we did was we said, well, what's currently in place? And we had our phone line system, right? Our phone lines were already all throughout the world, you know, I mean, throughout the United States, phone lines connecting everyone together. So we were like, well, if we use the phone lines to communicate, then they can't knock it out, because you knock one little piece out, there's other ways around it. And so the whole idea behind the internet was to have a system of communication that's not centralized, so you can't knock it out. You can't take it out, if that makes sense. And so like now the internet, like you can't undo it. You can't turn off the internet, you know? Anyways, okay.
But it's not dial up no more. So, right.
Yeah, that's right. So now, you know, they've changed it over to what we're really going like fiber optic now. And then we also have satellites, right? We have satellites too. So now if you want to communicate, you know, instead of trying to send the signal through the ground, you can just send the signal up into space and then bounce it back down, you know. But then that satellite's vulnerable, right? What if they knock out the satellite?
Yeah, yeah.
You know, that's a big fear right now is, you know, military is all about what they just started the space. What is it?
Space Force. Space Force.
Space Force, right? So it's an actual military branch now.
They just sent off yesterday. SpaceX just sent off a GPS system for Space Force yesterday from Florida.
Yeah, I mean, there's a big fear that if a country wanted to, they could take out our satellites are just sitting up there in orbit, right? If you take one of those out, you can cause some major problems. So you have to defend those. Anyways, okay, I'm way off topic. I apologize. Let's go to a different example now, okay? So I want us to look at something like, let's go with number 13.
Three terms. All right.
Yeah, x squared minus 6x plus 8. Now, I do want to mention to everyone here that I realize that some of you did this in high school, and if you know how to factor this without going through all the steps I'm about to go through, I encourage you to do that, okay? Because like I said, this usually in high school or something, it takes weeks to get through this. I'm trying to do it really fast. So I'm going to present a method to do this that should work for somebody who's never done it or never got comfortable with it. But if you already are comfortable, please stick with what you have because it's going to be faster. Okay. So if like, there might be someone here sitting here in the class right now that knows that this turns into x minus 2 times x minus 4. And that's because you did so many of these problems already in high school or wherever else it was, you can just do that kind of automatically. And that's great. If you can do that, I'm happy. But if you don't know how to do that, then we're going to go through the process. So the first step is GCF. So do they all have something in common? No, no GCF. Okay, so now we count the terms. How many terms do we see?
2,
3 this time,
oh,
right?
yeah, 3, 3. Yeah.
We have 3. 1, 2, 3 terms. So if we have 3 terms, we're actually going to use what I refer to as the AC method. So not grouping here, right? It's the AC method. So here's how the AC method works. The AC method goes like this. So we're going to do the AC method. Okay, and let's not worry about where the name comes from, AC method. I can explain that later. What you're going to do is you're going to first look at your 3 terms, make sure that they are what we call descending order, which means you have your x squared term first. That's the highest power of x. Then you have x, and then you have 8. What I'm saying is you don't want to try this. If it's written this way, that would be 3 terms, but it's not in descending order, right? The x squared's in the middle. You need the x squared out front, then the x term, then the 8 by itself. So you have to be in descending order first. Okay, so we are. So what you do is you look at the number in the front of the x squared. You look at the number, the coefficient, 1. And then you also look at the number back here by itself, and that's positive 8. Okay, so we have the number 1 and the number positive 8. And what you're going to do is you're going to take those numbers and multiply them together. 1 times 8 gives you 8. Then what you're going to do is you're going to look at the number in the middle, the coefficient on the middle term, and that's negative 6. And we're just going to write that down. Okay, these are our kind of like our 2 little magic numbers here. What we have to do now, and when I say we, I mean you, and you have to do this kind of in your head or on a calculator or however you get comfortable doing this, you have to find right now, you have to come up with 2 numbers that multiply to be 8, but add up to be negative 6. So you need to think about 2 numbers that when you get 8, but when you add up the 2 numbers, you get negative 6. So here's an example, the number 1 and the number 8. Do you agree that those 2 multiply to be 8?
Yes.
Okay, but do they add up to be negative 6?
No.
No, they don't. So it can't be 1 and 8. What's another possibility? How else could you get 8?
4 times
4?
negative 2.
How about 2 times 4? I heard you with the negative, but we'll wait on that for a second. 2
Okay.
times 4 would give you 8, right? But those 2 numbers add up to be positive 6. So we're close, right? We're close, but that's not going to work. So what about, I heard negative 2 and negative 4. Negative 2 times negative 4 should give you 8.
I meant one
Neg-
negative on one of the numbers.
Pardon me?
I meant one negative on one of the numbers.
On only one?
Yeah.
So what would happen there? If I had negative 2 and positive 4, what would that multiply to be though?
Oh, okay. Yeah.
That'd be negative 8, wouldn't it?
Yeah.
We want it to be positive 8. So you'd have to have them both be negative, right? So let's just check it. If I do negative 2 times negative 4, I should get 8. What about negative 2 plus negative 4? What if I add them up? What is that?
Negative 6.
Negative 6. And that's what I want, right?
Yep.
Okay. So this is a little bit of like trial and error. You have to figure out what the 2 numbers are. I'm going to highlight them. Those are our numbers, okay? Those are our numbers. Now, what do you do with them? So check this out. What we're going to do is we're going to rewrite the original problem. And I am intentionally leaving the middle space blank. So I just wrote the x squared, right, as x squared. That's supposed to be a plus 8. I wrote the plus 8, but I did not rewrite the minus 6x. Do y'all see that? I did not rewrite that. I left a big space in between. What we're going to do is we're going to rewrite negative 6x, but we're going to do it in a slightly clever, weird way. We're going to actually write it as two different pieces. And we're going to use the two numbers we just found. So I'm going to write that as negative 2x's minus 4x's. So all I need you to do is agree with me that negative 6x is the same thing as negative 2x take away 4x. Do y'all agree that that's the same?
Yes.
Okay. So why in the hell would I go through this trouble? Why do that? Why rewrite negative 6x as something more complicated? Can anyone tell me what I'm going to do now?
Grouping.
That's right. How many terms do we have now? We have 4 now, don't we? We have 4 terms. We've turned 3 terms into 4 terms, but we had to do this weird thing over here on the side. So now I go past my second term, put a little divider, pull out a GCF on the first one. And then on the second one, what can we pull out as a GCF? Be real careful here.
-4.
Negative 4. So you've got to get pretty comfortable with this idea of GCF, because all the methods that we're going to be using here, whether it be grouping or AC method, are all going to require that you're doing these little GCFs as you go. So we pulled a negative 4 out so that when we multiply this through, we would get back the original here. And more importantly, the x minus 2's match, don't they?
Yep. So that's why you were saying.
Pardon?
That's why you were saying that in the beginning, something about you need to know how to do 4 to do 3 or something like that. You were saying
How to do
something about. Never mind. I forgot what you said.
Okay, let me show you a slightly different approach to this, and I like this approach. Okay, at this point right here, when you've taken the first 2 terms and you pulled the GCF out, you pulled the x. At this point, don't we know that if grouping is gonna work, right? If it's gonna work, what would have to be in that parenthesis? What would have to be there?
X -2.
X minus 2, right? That would have to be there. So maybe you just write that down and then you just ask yourself, what the hell goes here? Right? Like, what would you have to multiply this times this to get this up here? What would have to be the question mark? Or what would the question mark have to be to get negative 4x out when you distribute that?
-4.
You'd have to have a negative 4, right? So why don't we put a negative 4 here and then just double check that it works. Here to here, that would give me this first one. Would the second one work? Negative 4 times negative 2? Give me 8? Yeah, that works, right? It's just a slightly different approach. It's like you write down what you need it to be and then you figure out what needs to distribute through, as opposed to looking at this and trying to pull a GCF. Either way, you get to the same result, and that is this line right here. And now that those 2 things match, we write down the thing that matches, another set of parentheses, and then we write the 2 things in front, and we are done. And so if we FOIL this out, right, if we were to FOIL it, we should get back the original problem. So do you see now why we learned 4 terms before 3?
That's what you said.
Yeah, because in order to do 3, you have to be able to do the grouping, right? So Okay, let's do another one. Let's do something like number 20. 3x squared plus 6x minus 24. You know what? Yeah, we'll do it. All right, so what's our first step?
GCF.
GCF.
GCF, right? Do we have a GCF? Is there a number that goes into 3, 6, and negative 24?
Three.
Yes.
3, right? Good. So we can actually pull a 3 out first. Oh, it looks off. So if I pull a 3 out, I will have an x squared plus 2x minus, what is that, 8? Do we all agree with that?
Hmm.
Okay, give me a second. I've got an issue here. Oh, no, that's not what I meant. Where's my thing? Where is it? There it is. My calibration is off on my pen. It's making it difficult. Okay. Okay, so we pulled a GCF. Great. Now, we have to focus all of our attention now on what's inside the parentheses. How many terms do we have?
3.
3. Okay, so since we have 3, we're going to use the AC method. And that means we need to identify the number in front. Be real careful here. The number in front is a 1. We're not even looking at the 3. The 3's already been pulled out. All right. So we're looking at the 1 and we're looking at the negative 8. We're going to write that down. 1 times negative 8. That gives me negative 8. And then we look at the number in front of the x, which is positive 2. We need 2 numbers that multiply to be negative 8, but add up to be positive 2. So this is where you get to just mess with numbers. Some people are really good at this part. Some people, they struggle with it. But, you know, just get a calculator out if you need help. You just have to come up with these numbers, though. Anybody?
Negative 2 times 4.
Okay, negative 2 and positive 4. What do y'all think? Well, let's check them. Negative 2 times positive 4, that gives you negative 8. And negative 2 plus 4, that does give you 2. And that works, right?
Yeah.
That's what we wanted. We wanted them to add up to be 2 and multiply to be negative 8. Okay, so now let's use that. I'm going to come back over here. Here's my 3. Here's my parenthesis. I rewrite the x squared. I rewrite the minus 8. But that middle piece, the positive 2x, is not going to be rewritten as 2x. It's going to be rewritten as what? Got to use our numbers, right? So how do I write it?
Negative 2x
Minus 2x
plus 4x.
plus 4x. Good. And now we've created the 4 terms. We've got to come in here and slash this thing right past the 2x. All right. Now that 3 out front, I realize that 3 out front is probably bothering you, but let's just keep bringing it down. So just put the 3 and then the parentheses, and let's just keep working on this piece here. So what is the GCF of the first 2 terms over here? What do we have? What can we pull out of those?
1.
1x, right? Just an
Yeah.
x. And we'll be left with x minus 2. Oops. Sorry about that. And then how about the other one? do y'all like that method where I just write down what it needs to be? Like, I know it has to be x minus 2 now, if it's going to work, right? And then just try and figure out what that number has to be. What would that number have to be to get me back 4x minus 8?
What's the 4, right?
Just 4, right? You
Yeah.
just need a 4 here. And it would have to be positive 4. So I'm going to put a plus there, plus 4. And you could just do a quick little check for yourself. If you multiplied 4 through, right, here and here, you would get back those two terms. So they match, right? So watch how I'm going to write this. 3, big set of parentheses. Now, all of this in here turns into the x minus 2, then another set of parentheses, x plus 4. And then I actually don't need that parentheses way out there. I can just put it over here. There you go. See that? I'm going to do one more, and then I'm going to let you try one. Let's see here. Let's do one of these ugly looking ones, like number 24. 7x squared plus 16x minus 9. There we go. All right. So do we have a GCF? I don't see a number that goes into all those. We definitely don't have an X that goes into all of them. So there's no GCF. I count the terms. I've got 3. So I've got to use the AC method. So I'm going to take the number in front here and the number in the back here and multiply them. Dang it. 7 times negative 9. That gives me negative 63. I need 2 numbers that multiply to be that. And then I take the number in the middle, which is 16, and I need them to add to be 16. Ooh. What do y'all think?
I mean, can it be 7 times negative 9?
You could use 7 and negative 9. I mean, they're definitely, those do multiply to be negative 63, but what do they add up to be?
Oh, that's right. I got confused. My bad.
No, that's good. I'm glad you're asking. It might have worked. It just doesn't in this case because they multiply to be negative 63, but they add up to be negative 2, and we need it to add up to be 16. So those numbers won't work. What other numbers multiply to be negative 63? How about 3 and negative 21? Isn't that negative 63?
Yes.
But what do those add up to be?
Not gonna be 16.
Is that negative 18? Something like that? It's not going to work. Can you think of any other numbers? How about 1 and negative 63? Those multiply, right, to be negative 63? But they definitely don't add up to be negative 16 or to positive 16. What do y'all think?
I think this one's hard.
Yeah, this one's hard. What you would have to do here is you would have to list out all the possible factors of 63. So 1, you go 1 and negative 63. 2 doesn't go in there. 3 goes in there 21 times. 4 doesn't go in there, 5 doesn't go in there, 6 doesn't go in there, 7 goes in there 9 times, 8 doesn't go in there, 9 you already know goes 7 times. So at this point, these are the only ways you can get negative 63. Of course, you could change where the negative is, right? You could do those also, but it doesn't, none of those give you positive 16 when you add them. What does this mean?
It's not factor. It's not a.
Yeah, we can't do it.
You
Okay.
can't factor it.
So what we will say when we get to a problem like this is that it is prime. Prime means it can't be broken down.
So all we do is just put prime down and that's
Yep.
it.
That's it. So if on your homework you get to a problem where you're trying to come up with these two numbers and you can't come up with them, the answer would be prime. That is prime. It can't be a factor. Now, I want to change the problem so that we can work it. What I'm going to do here, change the problem up. I'm just going to change that positive 16. I'm going to do it in a different color so you know I changed it. I'm going to make it positive 18 instead. Okay, so all I did was change that. So all that would change over here is that instead of needing it to add to be 16, we need it to add to be 18 now, right?
Yep.
And do any of these work? I mean, I know this one's not going to work. You know, that one's not going to work. But look at that 3 and the negative 21. I almost have it, don't I? What would I need to change on that?
Negative 3 plus 21.
Yeah, make it negative 3 and positive 21. Then it would still multiply to be negative 63, but now because this is negative and this is positive, that would be positive 18. So our two numbers are negative 3 and positive 21. So that means you could take this problem, you could rewrite the first term, leave some space, rewrite the last term, and then you're now going to split the 18x. How? How's that 18x going to be rewritten?
Negative 18.
No, remember you have to use the two numbers, right? The two numbers.
Yeah.
So negative 3x
Oh, yeah, negative 3.
plus
21x.
21x, right? That's the way we'd write it. Now you have 4 terms, so you can split it. Do we have a GCF in the first 2 terms?
X.
Just x, okay. And what would we be left with if we pulled an x out?
7 minus 3.
7x minus 3, good. And then let's just do that over here. Let's just throw that 7x minus 3 in here and let's ask ourselves what this number out here would have to be in order to get back what's up here. You'll see what it would have to be.
It would be 3, right?
3, yeah, positive 3. So I'll put plus 3. You can check it. If you distribute that through, you get 21x, and then you get minus 9. And they match, right? So I can put 7x plus 3, and then x plus 3. There it is. If you were to, wait a minute, I wrote down plus 3 there. Sorry, that should be minus 3.
That's what I was gonna say. Yeah, it's fine.
Yeah, sorry about that. So if we were to FOIL that back out, if you did that, you should get back this. Okay, it is 12:10. Let's take a break.
Hey, okay, never mind.
Sure.
No, I know the next part to put. Okay.
Okay. Let's take a break. I think this is a good opportunity to take a break. And, you know, if you, let's say it's 12:09, let's take a 10-minute break, be back at 12:20. But if you're just sitting there, you know, and want to, you can try any of these problems if you'd like. while you're sitting there kind of waiting. And I'll be back in 10 minutes.
You don't have any issues for stuff like that, Mom? Bites?
Okay, I think we'll pick things up here. I wanted to work number 28. I thought that was an interesting example because it has a slightly different form to it. And I'll try and work it right here on this page. So we have three terms, right? We look for a GCF, and there's no number that goes into all three of these. So we move on and we try our AC method. So the thing that's different is that this has, 12x squared, and then we have xy and then another y squared. So the main thing to kind of notice here is that we've got something squared in the front, something squared in the back, and in the middle we've got some other term. This is not the form of any of the other ones, right? So it's a little different, but we're going to do the same method. Let's just see what happens and see if it'll work. So we take our 12 and our -6 and we multiply those. So what is 12 times -6? That's our first thing. So I think we get -72 there. And then we take the number in the middle, and be careful here, that's a 1. So we need two numbers that multiply to be -72, but add up to be 1. And do we have those numbers? How about 9 and -8? That should work, right? Okay, so if that works, we should be able to do 12x squared in the front here minus 6y squared in the back. And then we're just going to rewrite this 1xy using the two numbers. So I'm going to write that as plus 9xy minus 8xy. Are there any questions on that step? Okay, we should be able to now break that down, do it, splitting it, first two terms, second two terms, pull a GCF. So that's kind of a weird GCF on this first one. We've got 3 goes into both of those, and there's an X in both of those. So if I pull out a 3X, I should be left with a 4, an X, plus a 3, and then a Y. So you can double check that for yourself, that GCF does work. And then in the other parenthesis, we're going to need this to match up. So I need 4x plus 3y. So what number would I need out front there? Anyone?
Positive?
Okay, positive what?
2.
2.
2, okay, so 2. So if we put positive 2, then we multiply the first, aren't we going to get a positive 8x? I forgot my y, sorry, everyone. Oops. Okay, so we need a positive 2, but if we multiply that, we're going to get a positive 8. We need a negative 8, don't we? So why don't we make it a negative 2? So negative 2 times 4x would give us negative 8x, but what else do we need there with the negative 2?
A Y.
We also need a y. So now if you multiply the first two together there, you get a negative 8xy. And then when you multiply the second one, you should get a negative 6y squared because it's y times y. So it matches up exactly. And now that you have this step, you can go ahead and just write down what matches. And then a separate parentheses, you write the two things that were in front, 3x and then minus 2y. That problem's a little different, but it works out the same, but there's slight differences in that GCF part. So I want to move on to the next part of factoring, which is going to be what happens when we have two terms. So before I do it, I want to kind of do this backwards. I'm going to give you a couple of things to look at here. We're going to try and notice a pattern. I'll give you a couple of examples. Okay, so there's 4 examples. Now, when you look at those expressions, those are already factored, right? It's 2 things being multiplied together. So what I'd like for us to do is FOIL these out, and I'm going to go through this pretty quick. If I FOIL this out, I'm going to get x times x gives me x squared. Get x times -2, that gives me -2x. 2 times x, which gives me positive 2x. And then 2 times -2, which gives me -4. The middle terms cancel out, and I'm left with just x squared minus 4. Okay, let's just leave that there. Let's look at the next one. If we FOIL here, we're going to get x squared minus 3x plus 3x, and then minus 9. And then again, those 3 x's cancel out, so you could just get x squared minus 9. Okay, let's look at the next one. 2x times 2x is 4x squared. 2x times -5 is -10x. 5 times 2x is positive 10x. And 5 times -5 is -25. The middle terms cancel out, the 10x's cancel, I get 4x squared minus 25. All right, last one. 1 times 1 is 1. 1 times 3y is 3y. -3y times 1 is -3y. And lastly, -3y times 3y is -9y squared. The middle terms cancel out, the 3 y's, and I'm left with this. All of these have something in common. Do you see that in the very beginning, on all of these problems, they're the exact same expressions. The only difference is that one of them has a plus, the other has a minus. One has a plus, one has a minus, one has a plus, one has a minus, one has a minus, one has a plus. Otherwise, they're exactly the same. You know, it's got an x and a 2, an x and a 2. The second one has an x and a 3, an x and a 3. It's just the sign in between that's changing. And do you also see that in all of these problems, when you FOIL them out, the middle terms cancel every single time? That is not coincidental. That always happens. So anytime that you have an expression, where you have, let's say, x plus some number, I'll call it a, and then you have x, and then you do minus some number a, you can always be guaranteed that when you FOIL this, you will get, let's see, what do we get? This x squared comes from that first multiplication, so we should get x squared here. And then the other piece is always the last 2 being multiplied together. And so we should get down here minus a squared. All of those have that pattern. And this right here is a formula that is a very common formula. This is called the difference of squares formula. And what it allows us to do is it allows us to work backwards. If we see something like this, then we know that it can automatically be turned into that. So let's do an example. So let's say we started with x squared minus 9, and you're asked to factor this. Okay, is there a GCF? No. How many terms do we have? 1, 2, right? We have 2 terms. So we're not going to do grouping. We're not going to do AC method. What we're going to do is we're going to see if this is a difference of squares. So do we see something being squared here? Well, yeah, right? We see the x being squared. Is 9 something squared? What number squared gives you 9?
3.
3, right? So since those are both, we're basically looking at this side right here. We're saying, okay, we have x squared and we have some number squared. This tells me automatically, without doing any work, that it's going to be x plus 3, x minus 3. And there's nothing else we have to do. Let's do another one below it. These should be real fast once you catch on to them. Okay, there's no GCF, there's 2 terms. Do we have something squared minus something else squared?
Yes.
We do, right? So this should turn into what? What goes next to those x's?
+4 and -4.
+4 and -4. How about this one? Okay, so no, oh, we do have a GCF here. Let me change this, sorry. Let's make that 4x squared minus 49. Okay, so no GCF. We have 2 terms, so we're asking ourselves, you know, is that something squared and is that something squared? Now be careful here, because we have 4x squared in the front, not just x squared. So what would go into the front of these parentheses? It's not just x.
2x.
2x, good. It would have to be 2x. And think about it this way. When you do that first multiplication, you have to get 4x squared, right? So you need the 2 and the 2 to multiply to give you the 4. Okay, and then it's just going to be plus, minus. Now, what number do you square to get 49?
7.
7. So you go plus 7 minus 7. Is this kind of making sense?
Yes.
Okay. What about this? X squared plus 9. Okay, it's a different problem. So the question is, can we use that formula? Can we use this up here? Well, the formula says we have to have a minus sign, right? Must be a minus sign. Do we have a minus sign between these two? X squared plus 9. We don't, right? And because we don't, the formula doesn't work. And so we would say that this is prime. We cannot factor it. We can only use a difference of squares formula if we have the difference, which means subtraction, of 2 things that are being squared. So once you kind of get this, the actual problems aren't that bad. Let's take a look at them out of the packet here. Okay, let's look at number 29. So 29, we have 2 terms, right? There's a difference. So we already did this one kind of. It would be x plus 7, x minus 7. Does someone want to tell me about number 30? What 30 would be?
2x plus 9.
Good.
And 2x minus 9.
There you go. How about number 31?
Wouldn't that be a prime?
That's prime. Good. Okay, what about 32? 32 is a little bit different. So what's the first step for factoring anything? What's the first step?
GCF.
GCF. So when you look at that, I can actually pull a 2 and an x out to start. Okay, so I'm not doing any formula, difference of squares or anything. I'm just pulling out a GCF, which is always the first step. If I pull out a 2x, what would I be left with? So if I pull 2 out of 32, I have a 16 left. I still have an x squared left because I pulled one of the 3 x's out. What's still left for this piece? What would I have to multiply 2x by to get negative 2x?
-1.
-1.
Negative 1. Yeah, negative 1. Good. Now, very carefully, look at this piece. 2 terms, right? That should turn into a difference of squares. Should be something and something. Notice I'm just putting the 2x out front because we had already pulled the 2x out. So who wants to tell me what would be in those parentheses? So you need to get a 16x squared. So how are you going to get 16x squared? What times what?
4.
4x and 4x, then a plus and then a minus. And then you look at the number in the back, 1. And the only way to get 1 is by doing 1 times 1. What about number 33? Two terms, right? You could pull a GCF, you could pull a 25 out and be left with x squared plus 4. You could do that. But the x squared plus 4 you can't do anything with because it's a plus, not a minus between those. So you're pretty much, this is it, this is your answer. How about number 34? Is that a difference of 2 squares? What would it become? What do you think? Lorenzo, you getting this? You're muted, by the way, Lorenzo.
Wouldn't it be 7 plus
Oh, yeah.
x?
It would be 7
So
plus x,
Plus,
and then 7 minus x. Good.
so we have to make sure we put the 7 in front.
Well, because the 49 came first, right? The
Yeah.
49 was in front, so we get, you want your first multiplication, right, to get you that 49. And you want your last multiplications to get you the x squared, so that's why the x's go in the back. Okay, on number 35, I would do a GCF first of x. I'd pull an x out first. And then once I do that, the x squared minus 1 is going to be x plus 1, x minus 1. So this piece here turns into those 2 pieces. But you have to pull that GCF out first. Okay, I think that that's probably enough at this point. You have a homework assignment for this. So you can see it's a bunch of factoring. So see how it goes. Yeah, see how it goes. You know, each of those problems you'll want to do, you know, GCF first. Okay, count the terms, 4, 3, or 2, right? If it's 4, you do grouping. If it's 3, you do AC method. If it's 2, you hope that it's a difference of squares. But always remember the GCF first. Okay, now, let's see if we can go to the next step, which is to figure out how to solve equations by using this technique of factoring. All right. So I have to start this out by explaining something to everyone. There's this thing that we call the zero factor property. Okay, the zero factor property. This is a very, very special property, very important property in mathematics. Here's what it says. If you have two things, let's say A times B. If you have two things that when you multiply them together, if they equal 0, then either A is 0 or B is 0. All right, let me try and explain. So what if I had this? What if I told you that I have x times x plus 5? What if I told you when you multiply those together, you get 0, right? So this is me trying to explain what's going on here. So if I tell you that two things multiply to be 0, this property is saying, well, then one of them has to be 0. There's no way to get 0 without one of those two things being 0. So you want to kind of look at this as being like the A is the X and the B is like this entire thing. So if those two multiply together, right, times, if they multiply to be 0, then what can I say according to this property?
The A is 0.
That either A is 0, this means that X equals 0, or what?
Or the B is 0.
The B is 0, but the B is the X plus 5.
Yeah.
Equals 0, right? So with that problem, I actually have now two problems. Either X is 0 or X plus 5 is 0, so I could subtract 5 from both sides, and that would tell me that X has to be -5. That's a linear equation. This right here is a linear equation. Linear equation, one variable. We've already studied these. So we just subtract 5 on both sides and we get X is -5. So what am I saying? I'm saying that if we have an equation, that if we can factor it, then all we have to do is set each factor equal to 0. And that's why this is called the zero factor property. You have to be very careful with the zero factor property because the 0 here is important. Let me show you. What if I tell you that two numbers multiply to be 1? Does that mean that one of those numbers has to be 1?
No.
No. Can you give me an example of two numbers that multiply to be 1, but neither one of them is 1?
Nope.
Can anyone give me an example of two numbers that multiply to be 1, where neither one of those numbers is 1?
-1.
-1 and -1? Is that what you're saying?
Yeah.
Yeah, that would work. If we did
Oh.
-1 times -1, that would be 1, wouldn't it? But neither one of those numbers is 1.
Oh, okay.
Okay, here's another example. How about 5 times 1/5? Does that equal 1? Yeah, because you would just go straight across, wouldn't you? 5 over 5 over 5, 5 over 5 is 1. So 5 and 1/5, neither one of those numbers is 1. So what I'm getting at is if you say that two numbers multiply to be 1, to be a number, that doesn't mean that one of those numbers has to be that number. It only works when this is a 0. If this is 0, then I guarantee you that one of those has to be 0. There's absolutely no way ever that you'll be able to take two numbers and get them to multiply to be 0 without one of them being 0. You can sit here the rest of your life. You're never going to find two numbers that multiply to be 0 without one of them being 0. Okay, so this property only works when we have some equation equal to 0. And so that's what this is about now. This is about, okay, can we solve this equation? Can we solve an equation using factoring? So let's look at number 1 here. We have 9x squared minus 16 equals 0, all right? But we just looked at 9x squared minus 16. Didn't we just talk about just right before this that we could factor 9x squared minus 16 because it's two terms, isn't it? And it has the form of difference of squares. So we could rewrite this as what times what, and then still keep the equal 0. So what could that be? Or what does that turn into according to our formula? What do y'all got? You need two things that are going to multiply together to be 9x squared.
Well, 3, right?
3x, right? 3x. And then you need your last number to be 16. So we know it has to be plus in one of them and minus in the other. So what number times itself gives you 16? 4, right? So we've factored the left-hand side, but now we can look at this as being our A and this as being our B, and we have multiplication between them now, right? So we're saying something times something equals 0. So that means one of them has to be 0, right? One of them has to. So I'm now going to create two equations. The first one is 3x plus 4 must equal 0. And the other equation is 3x minus 4 must equal 0. And both of those are little linear equations that you should all be somewhat comfortable solving now. But do y'all see we have two different problems now to do? It's two different things. So the first one, I'm going to just subtract 4 from both sides. And then I'm going to divide by 3. And on the second one, I'm going to add 4 to both sides and then divide by 3. So if you would like me to solve this equation, if you want me to tell you what x values will make that equation true, then x needs to be -4/3 or x needs to be +4/3. And those are our two solutions. Are there any questions on that one? No?
Can you go over another problem? Because
Oh yeah, I'm going to go through a couple of these.
yeah, this one's like confusing.
Okay, let's look at number 2. We have an equation. You must make sure you understand that we have equations now. If you look at the homework problem, the homework set right before this, notice all of these problems, none of them are equations. You're just being asked to factor, 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 factor. Now we're actually being asked to solve equations using factoring. So we have to notice we have an equal sign. And the only way we can do this is if we use the zero factor property, which means we need the equation to be equal to what on the right-hand side? What needs to be over here?
0.
0. And right now we don't have 0, do we?
No.
In the previous problem we did, but this one we don't. So the first step for me is to take this equation and just subtract 9 on both sides. Okay, so I'm going to have x squared plus 8x, and then 16 take away 9, I get 7 equals 0. Now we have something equal to 0. The problem though is that what's here in yellow is not factored. It's not something times something. So I can't use the zero factor property. I must turn it into something times something. But this is where we go through and do the procedure that we just learned, which is to factor, right? So do we have a GCF on the left-hand side?
No.
No, okay.
No.
How many terms do we have?
3.
3, okay. So this is where you do your AC method. Right, and I think I'll do the AC method here. Let's just run through it real quick. We have a 1 out front. We have a 7 in the back. We do 1 times 7, that gives us 7. We look at the number in the middle, it's +8. We need two numbers that multiply to be 7, but add up to be 8, and those two numbers are 1 and 7. So then what I would do is I'd come over here on the side, I'd rewrite the problem. So notice I'm doing all this on the side. I'm going to come back to the problem, but I need to factor the 3 terms first. So I've created 4 terms now by using the AC method. I pull a GCF out of the first. I pull a GCF out of the second 2. And that tells me this turns into x plus 1 times x plus 7. Now I know I worked fast through that. Okay, so I understand that this whole step over here is going to take you more time. We just covered that. You haven't even done the homework on that yet. But after you do homework and get comfortable with it, I'm trusting that everyone can do that step given enough time. But since we're in a new section, I've got to keep moving. So I'm just going to write down on this next line, that means that x plus 1 times x plus 7 equals 0. And now do you see that we have kind of like that a times b equals 0. So what we do is we set each one of them equal to 0. And I'm out of room. So I'm just going to do it right here. This means that x plus 1 equals 0, or x plus 7 equals 0. And those two little linear equations are pretty easy to solve because you just isolate the x. Subtract 1 on both sides, subtract 7 on both sides, and you have your 2 answers, -1 and -7. Okay, I'm going to write the next one down. I'm going to copy this. I'm going to take this to a new page. And I want y'all to, I want to see if y'all can work this one out. I'm going to give you a few minutes and then we'll talk. Let's say it's 12:55. Let me give you about, I don't know, I think 10 minutes is too long, but let's just go at 10 minutes. I'm going to give everyone 10 minutes to see if you can work this problem out. And I'll just guide you again. The first thing you want to do is get the equation equal to 0. So that means you got to get everything to one side. Whatever you have on that side, you need to factor it. Once you factor it, you need to set each factor equal to 0 and solve those equations. Okay, so see if you can do that. Y'all are free to talk to one another while I'm letting you work, okay? I was going to do breakout rooms, but I'll just leave everyone in here. I'll be right back.
So what's the first thing you do? You minus 2 from the other side? Or no?
Yeah. Well, that's what I did.
So it would be 2x plus 3 equals 7x, this, right? And then do we do, so 2x plus add.
I have a question.
What was that?
If that was 2x squared minus 7x plus 3, could you just not do, would just not work, or is that?
If it was minus instead, so let's just say like
Yeah,
you're looking at this side over here. If this had been a minus,
yeah, if
Okay.
that had been a minus.
we still could have done it because it would have been a minus here. Then if we used -1 and -6, that still multiplies to be +6 and adds up to be -7.
Okay, yeah, I see.
Okay, so I've put the work up here. Are there any questions about the work I went through? No? So you can see in a problem like this, there's a lot going on, right? You have to move everything over, so you gotta make sure you get your signs right. You've gotta go through the factoring process. And then after you're done, you've got these two little linear equations that you have to solve. So you gotta, move things around and divide. And you should come up with your solutions this way. Okay, let's go back and take a look at this here. Let's do one of these ones with fractions in it. Let's do number 8. So we've got x squared over 5 plus x over 4 equals 3 over 10. So, as soon as you see the fractions, you start to freak out. But we're going to handle them, all right? So because we're looking at an equation here, remember with equations, you can always clear the fractions. So I'm going to try and see if I can't come up with a least common denominator. So I look at all the denominators. I try and come up with the smallest multiple of all of those numbers.
20.
And so, yeah, 20 would be our LCD, least common denominator. Oops, LCD. 20 is a multiple of 5, 20 is a multiple of 4, and 20 is a multiple of 10. So what I can do is I can multiply the left-hand side of this equation by 20. So I'm clearing the fractions here. I'm going to multiply the right-hand side of the equation by 20. And when I do that, and I distribute through, you should get 4x squared plus 5x. And I'm gonna trust that when you put 20 on top there, 20 over 5 is 4 and 20 over 4 is 5. So that's where you get those two. And then on the right-hand side, you get like 60 over 10, which would give you 6. Okay, so now we don't have fractions. So we move everything to one side. So we're gonna get 4x squared plus 5x minus 6 equals 0, which is what we wanted. And now we proceed to factor. So I'm going to go a little faster through this. I've got -24. I need two numbers that multiply to be -24, but add up to be 5. Does everyone see where I'm getting those numbers from? What numbers do that? Anybody have them?
Three times -8.
3 times -8. Close. Because if we do 3 and -8, those add up to be -5, right?
Yeah.
You need it the other way around.
Mhm.
So how about -3 and +8? That should work, right? -3 times +8 is -24. And when you add -3 plus 8, you get 5. Okay, so that means I can rewrite my thing as this. So that's me rewriting the 5x as negative 3x plus 8x. And then I do my grouping. So I should be able to pull an x out. And then on the second one, I should be able to pull a 2 out. And since they match, I get 4x minus 3, and then x plus 2. So that means I can come back over here, rewrite this, and then use the zero factor property. So I set each one of those equal to 0. So I'll let you solve those on your own. But those are your two solutions. So you can see like things are, you know, we've kind of like built on things pretty quickly here. You know, we're solving little linear equations. Here we had to clear fractions. That's something we saw earlier this semester. So there's a lot going on here. Oops. Okay, I think the rest of these you could probably do the same way. I don't think there's any issues there. There's a lot of problems here. Okay, the homework assignments there. You know, I'm wondering, how do y'all feel? I mean, do you, what we've covered so far right now today is these two things right here. I'm getting this feeling like this would be a good time to stop, or should we push into simplifying radicals? What do y'all feel? Do you feel like you have?
I don't feel like I have this grasped down, so I wish like we should stop here. So we can,
Okay.
you know, I don't know. That's just my opinion, but.
Okay. How about the rest of y'all? Do y'all feel like you want some time to go and do the homework and get comfortable with everything before we move on?
Yeah, I feel like the homework will give us a little bit more time to grasp it all. And then if we don't, then we can still ask you questions before we move on to the next topic.
Yeah. Okay. I'm okay with that. Because, I mean, for me, ultimately, wherever we wind up at the end of the semester, you know, is where we wind up. But I feel like there's a lot here for you all to go through. I mean, all the factoring stuff and then all those equations. So I'm okay with that. We should be able to knock out this next section, next class, which would be what, on Monday? We should be able to cover all of this in one class, that first part. And then we'll just see what the applications, and then we still have a little bit of time. Our test is not gonna be, let's see, what's today? Obviously our test will not be next Wednesday. It's gonna be pushed out again. Everything's been pushed at least one day out. So I see our test happening on July 13th, probably. So, all right, well, let's do that. We'll just call it a day. And make sure you practice your homework. And then we'll come in on Monday and hopefully you'll have some questions for me. And I think that's pretty much it. I'll hang out for a minute. If you got anything you want me to talk about, I'll stay on here for a little bit. But if you're good to go, you can call it a day. Have a good weekend. Have a good 4th of July.
I have a question, sir.
Yes.
Just wondering about the recording. Are you gonna upload it today or tomorrow so I could like take notes about it and study?
Let me, you know what? I'll stop it right now. Let me stop the recording, and that way it'll come